Gentlemen, we are on our very last lesson of the school year. We have 12 days left of school, and this is lesson 12.5, the probability of compound events. Here's some warm-up problems if you would like to work on these things.
Mr. Opak, please call 6406.
And if we get interrupted a bunch of times, that's something that might happen. The last time you guys talked about probability might have been in chapter 0 if you did those things with Miss McKissick. You should remember a little bit of this stuff from last year. We're going to be talking about the probability of independent and dependent events, and we're also going to be talking about something that's probably new for you, which is that mutually exclusive events. So important things for us to write down are right here. We have the probability of independent events. That's two independent things, such as if I were to flip a coin and draw a card, and what's the probability of getting one of those heads or tails and maybe like 5 of hearts. So you'd multiply the probability of each of those things together to find the probability of both things happening. So we're going to get started with that exact kind of a process. Make sure you write this down. This is the symbolization of how we write that down. And this is a quick Venn diagram of what we are looking for of independent events. So here we go. We have this Ray. She's flying from Birmingham to Chicago with a 90% chance of being on time. On the same day, the chances of rain in Denver are 50%. What's the probability of her flight being on time and that it will rain? So 90% is 0.9 and 50% is 0.5. So if we just multiply those two together, we get 0.45 or 45% chance. That's pretty easy, isn't it? Now, I could have also written this as 9/10 times 5/10 to get 45 1/100ths, which would be the same as 45%. All right. Do that same kind of stuff to figure out your multiple choice question. That should be a fairly easy one for us. Now, the probability of dependent events is when we have something that the first event is completely independent, but the second event depends on what happened with the first event. So the probability of A times the probability of B after A. So that will change things for us. So here we go. Here's our example. At the school carnival, winners of the ring toss game are randomly given a prize from a bag that contains 4 sunglasses, 6 hairbrushes, and 5 keychains. Probably the worst prizes you could ever get, but I guess it is a school carnival. So these 3 prizes are drawn randomly from a bag and then not replaced. So find the probability of sunglasses, hairbrush, and keychain in that order. So there's 5 plus these 2 things make a 10, so there's 15 things. So the probability of us getting sunglasses will be 4 out of 15. Now, because one of those things is removed, we're now going to be out of 14 for our next event. So a hairbrush has 6 out of 14 hairbrushes, and then a keychain, there are going to be 5 out of 13. So all I have to do now is the simple math. So 4 times 6 times 5, 4 times 6 times 5 gets me to the top number being 120, and then my bottom number will be 15 times 14 times 13, and that is 2,730. And if I simplify those things, just type it in the calculator, I get 4 out of 91, and 4 out of 91 is the same thing as a 4% or 4.4%, which will be the same exact stuff. All right, moving on. See if we can do the same kind of a process here on this event here. We have probability of getting a red, a green, and then a blue. The correct answer is B. I accidentally gave that away for us, but you're going to find out that there are 16 plus 10 plus 18. So 16 plus 10 plus 18 was the total number of marbles, which is 44. So red marbles, there's 16 of them, Now there's going to be then green, there's going to be 18 out of 43, and then there are blue 10 out of 42. When you multiply your tops and then your bottoms, it simplifies to be 120 over 3,311. So that's the beautiful math involved here when we have dependent events. Let's try one more. This time I'll try not to screw it up. So we have the same 44 marbles or gumballs. A green one is 18 out of 44 chance. And then they're removed. And then blue, there are 10 out of 43. And then that's not red. Well, if we take one of the greens and one of the blues, we're down to 42 left over. So how many of them are not red is our next choice. So green and blue, that would be 28 of them are not red. And that's why we get their answer. When we multiply them, we get 195 over 3,311. All right, mutually exclusive events are if there are two events that are exclusive to each other, then the probability of them, A or B, occurs is the sum of their probabilities. So we're going to add their probabilities together. So the probability of A happening plus the probability of B happening. So if we have a standard deck of cards, so because these things cannot be drawn at the same time, they are exclusive events. So the probability of me drawing a 7, so there's 4 decks, which means, or 4 suits, which means there's 4 different 7s out of the 52. And that means there's also 4 out of the 52 that are 8. We add them together, we get 8 out of 52. And when we simplify 8 out of 52, we get ourselves the answer of 2 out of 13, or a 15.4%. And everyone's cool with how to simplify, hopefully, because all we gotta do is simplify by dividing both numbers, the top and the bottom, by 4 to get down to a 2 over 13. You could divide to get it into a percent form. All right, let's see if we can do the exact same kind of a process. The freshman club has 16 seniors, 12 juniors, 15 sophomores, and 21 freshmen. What is the probability that a member chosen at random is a junior or a senior? So we have 16 plus 12 plus 15 plus 21. And into my calculator I go. There's 64 people. So the probability, that's kind of weird. The probability, sorry it was glitching out on us, will be of a junior. There are 12 out of the 64. And now that the next one we're going to add together, a senior, there's 16 out of those same 64. So we add those together, they have a common denominator, so we can just add, we get 28 out of 64, and when we simplify, we can divide both numbers by 4 again, and we get the answer of 7/16, which is A. Sweet. Here's your open response question. See if you can figure this one out on your own. It'll be sweet for us. All right, now events that are not mutually exclusive, which means that we're going to have them add the two events together like we did before, and then we're going to subtract the combination of the two. So in this case, we have a bingo game with balls or tiles numbered 1 through 10. These numbers correspond to columns on a bingo card as shown on the table. A number is selected at random. What is the probability of being a multiple of 5? So a multiple of 5, that would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. That was 15. So the probability of getting a multiple of 5 will be 15 out of those 75, I guess, numbers. Or the probability of an n. So we're going to add to that, getting an n. Well, that's 1 out of the 5, but if we make this into common denominators, that's going to be, again, 15 out of 75. So we add those two things together, and now we're going to subtract the probability of it being an n and a multiple of 5. So 35, 40, and 45 are in this category. So that's the 3 out of the 15 of the 75. Sorry, 3 out of the 75 choices there. So when we do the math here, we get ourselves a 27 out of 75, which is going to simplify to a 9 out of 25, or 36%. Let's see if we can do that again. All right, so we have 7 boys who have brown eyes, 5 boys that have blue eyes, 6 girls have brown eyes, 8 girls have blue eyes. What's the probability if we have a boy or brown eyes? So there are 26 students. A boy would be 12 of those 36 because there's 12 boys here. And then we're going to add to it having brown eyes. So there's 7 boys, 6 girls. That's 13 of them that have brown eyes. And then we are going to subtract being a boy with brown eyes, which is the 7 out of that same 26. So we do the math here, and we get ourselves a 9/13. Hopefully this stuff is making sense to you guys. It's been a wonderful time with you guys checking in here on Burma Nation. This is my last time signing off. Have a great year.